Okay. So does anybody have a guess what this course is about? Anybody has a guess? From the name, perhaps? So the course is called Software Requirements and Analysis, right? So what do you think it's about? Yeah? Yes?
This course introduces the techniques as well as the system architecture design as part of the agile process.
Perfect. That's correct. Someone rephrase that. Rephrase that. Yes.
Putting together any kind of software-based project.
Yes. Yes, exactly. So we're gonna learn how to put together any software project. So this is the first step that we want to take when we approach a software project. Okay. So now we're gonna talk about software engineering. Okay. Your program, you're gonna be a software engineer, right? This is slightly different than a software developer or a software programmer. Okay. Software engineering is much more than just writing code. So engineering of the software involves writing code, that's the essential part of it, but there is much more around that, the development or the coding part that is required in order to have a successful project. So software engineering involves problem solving. Okay, so you're not just writing code, open an IDE and write code. You're trying to solve a problem, and this problem is relevant to someone. So you need to, you're trying to solve a problem for someone using this system. So there's problem-solving skills needed, the creation of a solution. Okay, creation of a solution, not just writing, open a file and write code that does something. That thing has to be relevant to the problem, and it has to be a solution to that problem. Okay? And it's not just a script or a program that you're creating a whole system. A whole system that utilizes scripting and programs and software. All right? So there's a modeling part, how to create models of that system to communicate with other stakeholders. And knowledge acquisition. Now, as a software engineer, most of the time you're gonna be working on projects that are not in your expertise. So let's say you were creating a system for a hospital. So that's some medical knowledge is needed there. You're creating a system for, let's say, a stock market. Some knowledge in finance is needed there. Okay. So as software engineer, you have to be learning about these systems that you're gonna build your software for. So you need to learn about it in order to really help it. And then there is a rational management, so the management of the project itself. Now, all these are part of the engineering project in addition to the development skills. Okay? Now, when it started as ad hoc. Like when programming generally started, it started in a very limited applications for scientific reasons. And ad hoc means there is no planning there. So someone who is a scientist typically would just have a problem, a scientific problem, and want to solve it. So they just solve it with code. So they open the code and open the system or open the file, start writing. That's how it started, ad hoc, without planning, just do it, okay? Now, nowadays, it has evolved significantly from that, and this ad hoc approach is not proper anymore, okay? So you're creating a software system with multiple components, multiple technologies involved, and all these components has to communicate with each other. So you have to think of it as a system. And in order to create a system, you need a process. Okay, so the creation of that system happens within a process with particular skills and activities and phases that you have to go through. Okay. Now, here's the generic situation that you will be working on. You will have a real system that you want to create a computerized system to help with. Okay. Now, the real problem that software engineers face, and it's a reason for the failure of most software projects, is that when you describe the real system that you want to create the computerized system for, you describe it in a human language, right? English or whatever human language. That human language is vague and ambiguous, and every statement can hold multiple meanings. So that's just the nature of human language. When you create a computerized system, you write it in a programming language, right? Is there any vagueness in programming language? No, like the line that you write is particular, very particular in action, and there's no meanings and no interpretations and no possibilities. There is exactly one meaning. You write a line of code, this one line of code has exact one meaning, right? Now, how can you move from vague, ambiguous, multiple interpretations into exactly one action or one meaning? How can you move from here to there? You have to choose one of those possible meanings, right? You have to choose one. And this one is the one that you're going to implement. Now, the real problem is that lots of developers just choose the interpretation that makes sense to them. That's the problem. What makes sense to you as a developer is not necessarily what the customer wants or what is needed by the customer. And that's why they always like, after spending all the resources and all the time creating a very sophisticated system, now the customer wants to see it. It doesn't work for them because this is not what they wanted. You just decided to choose one meaning that makes sense to you, but it's not really what's needed by the customer. Okay, so instead of getting into this situation and like you have the developer choose whatever meaning they're relevant for them or makes sense to them, you have to go through a particular set of steps in order to gradually clarify this vagueness of the human description. Okay? So these are the steps that are involved in the software development lifecycle. We can have a general categories for these, so general 3 categories that related to the requirements analysis. And there are some activities related to design, and then some activities related to implementation and testing. Now this line, now generally speaking, we have these errors. We aim at going through these activities in that order, generally speaking, but it's never linear. So just because it looks like a line doesn't mean it's an actual line. It's like you keep going back and forth between the different activities, and in reality, it's actually a cycle. Okay? But the general objective, we want to move from here to there, generally through these steps. Okay? Generally speaking, using this order. Okay? Now, if you Google software development lifecycle, you will get something similar to these. Okay, there will be some variations in the wordings. There will be some different language, but in general, more or less, it's pretty much that what we have here. Okay, we have some activities related to requirements, some activities related to design, and then the implementation and testing. So the activities related to the requirements are pretty much you trying to figure out what is it that we need to do. So that's the main focus of this course. What is it that needs to be done for this system? Okay, so we try to answer that question, what? In the design activities, we're trying to plan how are we going to do it? How are we going to implement it? So these are the what needs to be done. Now, how are we going to do it using a software system? That's the design activities. And then the implementation is the actual in place. So you take the plan and actually execute it, create the system. And then a very important step is the testing to verify. Whether what was implemented actually matched what was planned, and whether that was implemented and planned actually matches what is needed by the customer. Okay, and then it keeps going. So the cycle means like it keeps going forever. There's no point that you say, okay, I'm done, this is the end, unless you are retiring the system. Okay. So these are the activities that we have for software engineering. The requirement elicitation and requirement analysis are part of what we call the requirements engineering. So in themselves, the requirements engineering is a process in itself. So we have the process for the requirement for the software development. Within it, there is some sub-process that is specific to requirements engineering, and that's the main focus of this course. But not just that, because these other, like the system design, is also relevant to you when you create the plan, the requirement plan. Now there is a discipline called business analysis that overlaps significantly with requirements engineering. So a business analysis, the business analyst is a person who tries to figure out solutions for the business in general. Okay, so business has a problem. The business analyst will try to figure out what's the problem, what needs to be done to fix the problem. Oftentimes, this problem would be solved using a software system. That's when the overlap happens. The business analyst is pretty much the software engineering when we are talking about solution that is software based. Okay. Now, system design is also called architecture design. And even though the course is mainly focused on the software, the requirements engineering, but we're going to talk about the agile methodology in a little bit. Now, the lines between the different activities is becoming more and more blurry with the agile methodology. So we can't say like requirements engineering ends here and then we start a new process and forget about requirements. We can't do that. It's every step feeds in the other steps. And because the architecture design is the closest step to requirements, it's the one that is particularly affecting the requirements engineering most. Okay, so we're gonna touch upon architecture design a little bit after the reading week. Okay.